Hello listeners and viewers, welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned as always to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Hello and good day, my viewers, listeners, learners at home. You're welcome to yet the e-learning platform of Kaduna State's Ministry of Education. And today in chemistry, we'll be discussing a very simple topic, simple separation techniques or method. Sure, some of you will be wondering why it's important to treat this topic, even though it's one of the first topics you meet in SS1. It's important because you need this in your practical exam as well as in your theory exam, because oftentimes questions come from this aspect of chemistry. I'm sure you will sit tight with your pens and papers and follow me as we go through this aspect of chemistry. Now we start by definition and stating difference between mixtures and compounds, looking at purity of a substance, criteria for purity, types of mixtures. We'll be looking at homogeneous and heterogeneous, types based on physical states, criteria for choice of separation methods, and of course we'll look at the different separation methods like filtration, evaporation, sublimation, distillation, chromatography, magnetization, crystallization, and of course decantation. Viewers at home, I'm sure you must have learned about physical changes and chemical changes. Today we'll be looking at what a mixture is. In chemistry, a mixture is made up of two or more constituents or substances physically combined together, and they can be separated by physical means. Example of a mixture is blood, brass. Brass means zinc and copper mixed together, and so many other examples. I'm sure that some of you will be wondering if blood is actually a mixture. Those of you that have gone to the laboratory for test, you find out that your blood sample is taken and is placed on top of an apparatus. It's called a centrifuge. And these centrifuges rotate very fast. And at the end of the day, you will see two layers of blood. One that is colorless and one that is colored red. So you can see that actually blood is a mixture. Another thing we'll be defining is compounds. A compound is made up of two or more elements that are chemically combined together. Example of a compound is sodium chloride. An element sodium and chlorine come together to form a compound, and so many other examples. You can see other examples like tetraoxosulfate 6 acid, etc. Now I have to quickly differentiate between a mixture and a compound, because questions will arise like that in your examination and you'll be equipped with the answer. Now, one of the basic difference between a mixture and compound is that a mixture can be separated by physical means, while a compound cannot be separated by physical means. The other one is that components are not chemically combined in a mixture because there are no bonds broken and there are no bonds formed. But in a compound, they are chemically combined together because old bonds are broken and new bonds are formed. Then we have the formation of mixture is not usually accompanied by any heat change or energy change, but the formation of a compound is accompanied by chemical heat changes or energy changes. Then we have number 4. The components retain their physical and chemical property. Example, if you soak your garri in the afternoon, you want to take your garri, and eventually you decided that, oh, you don't want to take garri, you want to take indomie. You can filter your water out of the garri and dry your garri to become dry, and it will still be garri and water as it was at the beginning. But if it is a compound, you see that once you combine them together, you cannot take them back, so they will have the physical and chemical change of the new compound that has been formed. Then lastly, we say the component may be found in any proportion. I can bring a bucket of salt and a drum of water and mix them together in any proportion. But in chemistry, compounds are always in fixed or constant proportion. That is why your water is H2O. That means 2 hydrogen must always combine with 1 oxygen to give you a water molecule. That's the differences. There are so many other differences you can come across, so that when the exams come and you see a question like that, you'll be able to attend to it. Now, the next thing is the purity of a substance. In the layman context, when you say a substance is pure, what people look at is the color, the texture. For instance, we have a sachet water and we call it pure water. In chemistry, it's not pure water. Actually, there are so many other things that are inside that water that is not making the water to be pure. So when you say a substance is pure, it means it contains only 1 atom or molecule. That's when you say a substance is pure. But if it has other things in it, it is not naturally, it's not always pure. And how do we know that a substance is pure? It says the purity of a substance is the measure of the extent to which a substance is said to be pure. And that's why we can say the purity can be in percentage. You can say 99.9%, 50%, as the case might be. So how do we know that a substance is pure? The color, the texture does not matter. It doesn't tell you whether a substance is pure. What actually makes you know whether a substance is pure is these 4 or more things I will be calling now. First of all, fixed or constant melting point for solid. If a solid has a fixed or constant melting point, it means it is pure. For instance, pure water melts at 0 degrees centigrade. So when pure water melts above or below 0 degrees centigrade, it means it contains impurity. The other one is constant or fixed boiling point for liquid. If a liquid boils at a constant temperature or a fixed temperature, it is pure. For instance, pure water boils at 100 degrees centigrade. It's not every water that boils at 100 degrees centigrade. Let me give you a simple illustration. For those of you that cook at home, if you put your pot of water on the fire and the water starts boiling, remember the moment you introduce salt or Maggi, the water will stop boiling for some time before it starts boiling again. Why? Because the salt or Maggi becomes an impurity and it increases the boiling point of that liquid. So that is why we say a pure substance must have a constant boiling point or a fixed boiling point. Then we have fixed or constant density. it must have a fixed or constant density. Remember, your density is mass per unit volume. The density of pure water is 1 gram per centimeter cube. Anything outside that means that water is not pure. Lastly, which is the simplest one, is constant or fixed refractive index. A pure substance will have a constant or fixed refractive index. Now, there are phenomena associated with this. One of them we call melting point depression. The other one we call boiling point elevation. Now, what is boiling point elevation? It means the increase in the boiling point of a substance due to the presence of impurity. Earlier on, I mentioned to you that when you introduce salt to water, the boiling point of that water increases because of the presence of that salt, which is an impurity. So we refer to that as boiling point elevation. Another one is called melting point depression. What is melting point depression? The decrease in the melting point of a substance due to the presence of impurity. Oftentimes you see that in countries where there is extreme temperatures, like the polar regions, there is snow on the road, and for the snow to melt quickly, they introduce sodium chloride or salt. That salt acts as impurity. It makes the snow to melt quickly because impurity decreases the melting point of a solid. So those are the phenomena. So let's look at the type of mixtures. I'm sure that you are very conversant with the two types of mixture, homogeneous and heterogeneous mixture. Now, when you say a mixture is homogeneous or heterogeneous, homogeneous means that the components are evenly distributed in the mixture, such that your naked eye cannot separate the two components or more components in the mixture. For instance, if I pick sugar and pour it into a cup of water and I see it, stir it away, the sugar immediately disappears. You cannot see sugar, you cannot see water. So it means that the sugar and water are evenly distributed in the mixture. So it becomes a homogeneous mixture. On the other hand, heterogeneous mixture has components in which the proportion vary throughout the sample. Example, sand and stone. If I put sand and stone in a container, you will see distinctly the stone and the water. So it means that it's a heterogeneous mixture. Hence, the component of the eye can separate the two or more components that are in the mixture. Another example is your soil. In your soil, you have your topaz layer, which is the humus, and so on and so forth. Now, there is another classification of mixture based on physical state. That classification, I want us to look at it properly because it helps you in your choice of separation method. We have the solid to solid mixture, which is as in the case of salt and iron filling. Salt is a solid, iron filling is a solid. Now, if you know the physical state, the type of mixture based on physical state, you can choose the separation method. For instance, if I have this grounded corn, powdered corn, there is the very fine powder and there is the shaft. They are both solid. I can use a sieve to sieve them and get the powder and trap the shaft on top of the sieve. So you have solid to solid mixture, example, iron filling and sand. We have solid to liquid mixture, sugar and water. We have solid to gas mixture. Most people are not conversant with that. So cigarette is an example to solid to gas mixture. Then the next one is liquid to liquid mixture. Example is ethanol and water. Then we have liquid to gas mixture, which is carbonated drink. Example, Coca-Cola, Maltina. When you open them up, you hear sound, showing that the gas is coming up. Then the last one is gas to gas mixture, which is air. Air is a mixture of gases. My student learners, viewers, and listeners at home, we have criteria for choice of a separation technique. One of them is difference in sizes. Now, if a fisherman wants to go and catch big fish in the river, he will not go with a small net because obviously he will not catch a big fish. He will go with a big net such that the small fish can pass through the net. He can trap his desired component, which is the big fish. Then we have difference in solubility, difference in density, difference in rate of or speed of absorption over an absorbate medium, difference in magnetic property, and difference in boiling point. These are the criteria that we use to choose the different separation method. The first method of separation that we'll be looking at, or technique, is filtration. And this is a method of separating a mixture using their difference in solubility and sizes. It means that the solute must be insoluble in the solvent, and of course the particle will be of different sizes. Now in this type of separation, you use a porous material. In the laboratory we use filter paper, where the liquid passes through the filter paper and is collected as filtrate, while the solid particle, which is insoluble, is trapped on top of the filter paper and is called a residue. Now, the next separation method is evaporation. In evaporation, it is a method of obtaining soluble solid from a solvent. For instance, if I put sodium chloride in water and stir, the sodium chloride disappears, meaning it is soluble in the solvent. The only way I can get it back is by heating, such that when you heat the mixture, the liquid will now evaporate, leaving the solid particles in the evaporating dish. So you can see there carefully the diagram. But oftentimes we don't heat directly, as the case is here. We use another medium under the evaporating dish so that substances that decompose does not decompose. And that thing is called a salt bath, a steam bath, or a water bath. Even though it's not here, if you check through your materials, you will see it. Now, the next type of separation technique is separatory funnel or separation funnel. It is used to separate immiscible liquid, meaning liquid that cannot mix together. Now, you can see a separation funnel is used to separate immiscible liquid, where the less dense one will float on top, then the denser one, and of course the densest, is at the bottom. Then you can collect each of the components at per time. You can see we have them here. When you open the tap, you collect the first one. When you are about to end it, you remove it and bring another container like that until you have collected all samples. Then we have the next separation method, which is sublimation. Now, sublimation is a process where a solid turns into a gas without becoming a liquid, and turn back to a solid again. Now you'll be surprised, how does that happen? I'm sure some of you use Drummer Boys in your house, it's a room freshener. When you put it in your sitting room, it's a solid, but the room is overwhelmed by fragrance, and that fragrance is as a result of the emission, which is the gas that have been formed from the Drummer Boy, or the white camphor that you put in your box, and so on and so forth. So substances that can easily be purified or separated by this are iodine crystals, camphor, naphthalene, dry ice. When we say dry ice, we are talking about carbon 4 oxide in solid form, and of course ammonium chloride. So these are substances that can sublime. So if you see them in your examination, be quick to remember that sublimation can be used. Then distillation. Distillation is the evaporation and condensation of liquids. Now, this process of separation uses difference in boiling point, and that is why there are two types of distillation: the simple distillation and the fractional distillation. Now, simple distillation uses wide boiling point difference. For instance, ethanol, which is 78 degrees centigrade, and water, which is 100 degrees centigrade. So if you have these two mixture at 78 degrees centigrade, you start collecting your ethanol. And you can collect it maybe at 90 degrees before you start collecting your water at 100 degrees. At that point, you will have gotten your pure sample. So pure water in the laboratory is gotten by, it's called a distilled and deionized water, and it's gotten by this method. Now, the other type is called fractional distillation. And fractional distillation is used to separate mixtures that has close boiling point difference. Example is crude oil. When you get crude oil or petroleum, it comes in form of a component. But after separation, you get your gas, your kerosene, your petrol, your diesel, your bitumen, and so on and so forth, using this. The difference is that it has a fractionating column that separates this component easily. Now, chromatography. Chromatography basically, my student, take note, is used to separate pigments using their difference in rate of absorption over an absorbent medium. I'm sure when you are in secondary or primary school, you keep your blue pen in your white uniform, and when it leaks on your uniform, you discover that it spreads out to give you different color. That's an example of chromatography, and your shirt becomes an absorbent medium. There are different types of chromatography, but when you see things like chlorophyll, which is green from plant, ink or dye, be quick to remember that its preparation method is chromatography. Like I said, there's paper chromatography, thin layer chromatography, gas chromatography, just to mention but a few. Then magnetism is used to separate a mixture using their difference in magnetic property. If your mother sent you, for instance, to go and buy sugar in the market, and she gave you a knife to sharpen, you know these people that sharpen knife, they leave deposit of metal on the ground. We call them iron filings. So when you pour your sugar mistakenly in this iron filing and they mix, you'll be wondering, how do I get it back? It's simple. Get a tray, put them on the tray, get a magnet, put the magnet above. All the iron filing will be attracted by the magnet. And of course, sugar cannot be attracted by a magnet. So obviously at the end, you have your sugar and your iron filings. My wonderful students, as I conclude my lesson today, I hope that you remember that there are methods that we can use to purify substances. And this method involves more than one separation techniques. Example is crystallization. Now, in crystallization is when you cool a saturated solution. The crystal will surface, and after the crystals have surfaced, then you can now filter it. It's used to produce salt from seawater. Then other is precipitation and centrifugation. I remember I said centrifugation earlier on, when you separate blood from the serum to the red blood cells. I hope I have had time enjoying my lessons with you, and I hope you have also grasped the lesson. Meet me some other time. I will be doing another presentation. Thank you very much for being a wonderful audience, as I invite my noble colleague, Malam Ibrahim Umar, for the summaries of today's lesson. Have a blessed day.
Well done, Mr. Philip, for your wonderful presentation, and good day, my wonderful students. My name is Ibrahim Umar. I'm here to give a brief summary of the lessons that was presented, well presented by Mr. Philip. He starts by definition of terms, and he defines compound and mixture, because you have to know what a compound is and what a mixture is before you will be able to understand separation technique. And he said compound consists of two or more substances that are chemically combined together, while mixture consists two or more substances that are physically combined together. He moved ahead to give you the differences between compound and mixture, in which he said compound is physically combined together, while a compound is chemically combined together, while a mixture is physically combined together. A compound can be presented by a chemical formula because it has fixed mass of constituents, while a mixture cannot be presented by a chemical formula because the ratio is not fixed. And then you also move ahead to say that a compound is generally it's accompanied by a great change in energy or heat, while a mixture does not. And then he mentioned a lot of differences, which I mentioned 3 out of them. He moved ahead to talk about purity, and he said a pure substance is a substance that consists only one type of atom or molecule. And he moved ahead to tell you that if you want to test for purity of a substance, you can either use the melting point if you are talking about a solid, you can use boiling point if you are talking about a liquid, you can also use density and refractive index. Remember, the best criteria for testing the purity of a solid substance is the melting point, while the best criteria for testing the purity of a liquid substance is its boiling point. And also, you should take note of the fact that impurities generally increases the boiling point and then decreases the melting point. From there, he moved ahead to tell you types of mixture. He said we have homogeneous mixture and heterogeneous mixture. A homogeneous mixture is the mixture in which the substances are evenly distributed and cannot be seen by naked eyes, while heterogeneous mixture is a mixture which contains a substance that are not evenly distributed. Under that, he moved ahead to tell you separation techniques. What are the criteria for selecting separation technique to use? He said that you have to take note of boiling point, sometimes the sizes. You can take note of a lot of things, but size, boiling point, differences, the difference in solubility, and so on and so forth. Remember, he discussed them vividly. He only failed to talk about decantation, which is a method that is used to separate substances, a solid that is not evenly distributed in a liquid. If a solid is able to settle in a liquid, then the best method to separate is by decantation, in which you carefully take down the liquid, you pour off the liquid, leaving the solid behind in the container in decantation. And I take it again. In decantation, what you use is that if you have a solid that is heavy to settle at the bottom of your suspension, then what you do is you carefully pour the liquid away and then you retain the solid in the container. My students, have a wonderful day. I will invite Mr. Williams Ishaku to come and give you assignments to test if you understand the topic or you have some other problems. Thank you very much. Stay safe and keep learning.
Hi, my student. Once again, you are welcome. I'm so glad to be in your midst. As you all know, my name is Williams Ishaku. I believe you have learned a lot from this beautiful presentation. Don't forget, we're here to keep you learning, even at this coronavirus pandemic period. However, I would like to read out these questions for you so that you can try them at home and then get back to us to ensure that learning has taken place, whether learning has taken place or not, in case if you have any problem. The first question there is, define the following terms. A, physical changes. B, chemical changes. C, boiling point. Question number 2, what do the following, the A part of it, what do the following filtrate, distillate, and sublimate have in common? The B part, define boiling point elevation and melting point depression. Question number 3, describe how you can separate a mixture of iron fillings, ammonium chloride and sodium chloride and sand. Again, the first question, define the following terms. Question number 1, the A part of it, physical changes. B, chemical changes. C, boiling point. The second question, the A part of it, what do the following filtrate, distillate, and sublimate have in common? The B part, define boiling points elevation and melting points depression. The third question is, describe how you can separate a mixture of iron fillings, ammonium chloride, sodium chloride, and sand. I would like to give you a tidbit on how to answer question number 3. You can see there we have ammonium chloride, sodium chloride, and sand with iron fillings also. So the first method of separation you are supposed to apply is sublimation, magnetization, so that all the iron fillings that are in the mixture will be magnetized, leaving behind the remaining one. Then subsequently, the next one to do is to heat the mixture, in which sublimation will now take place, where ammonium chloride will sublime, leaving behind sodium chloride and sand. Then you can now add water to the mixture and then dissolve. The sodium chloride will now dissolve, in which you are going to carry out filtration method and evaporation method. By this, you have 4 methods of separation to describe. In case for further reading, if you want to read more about these separation techniques, you can always use the following textbooks. We have 1, Understanding Chemistry by Godwin O. Ojokuku. We have the second one, New School Chemistry by Osao Ayao Ababio. We also have the third textbook that you can also study is STAN Chemistry Textbook for SS1. The meaning of STAN is Science Teachers Association of Nigeria. And after the whole thing, in case you have any problem, you want us to come in, you can contact us via this number. We prefer you using WhatsApp. The first number there you can see is Mr. Philip Mama, 080-2659-8861. Again, 080-2659-8861. The next is Malam Ibrahim Umar, 070-3620-2842. Again, 070-3620-2842. Next is my own, Williams Ishaku, 081-606-70920. Again, 081-606-70920. Thank you very much, my student. Remain blessed, stay safe, and keep on learning. Don't forget, if you want to learn, nobody can stop you. If you don't want to learn, nobody can force you, according to Zig Ziglar. Thank you. See you another time.